Okay, so I give you the paper, you can write down. So the main thing for hydroxy compounds is oxidation and reduction. I feel this is the main thing. Right? This is the main thing that you need to know, right? So what is the oxidation? What are the different alcohols? Any idea? Okay, what are the different alcohols? Primary, right? So primary alcohol, okay, you can copy as you listen or later on, probably I'll give you a lot of time. Right? Primary alcohol, we oxidize to form ethyne. This is correct. Ethane. Yes, ethane. What is it? Can you remember not? Oxidize to form what? So A. Which after that oxidize to form, so I see. L. Okay, that can help her. Yes, aldehyde. Okay, which oxidize to form carboxylic acid. Let's summarize one, don't worry. We spend more time practicing. Okay, teaching should be just half an hour or so. Very easy like that. Okay, but actually you must include another line that if I oxidize, right, it might go directly to this, right? So be careful. Okay, let's draw as I go. Okay, this is a very good summary and you need to study not so much, spend time practicing. That's aldehyde as well. Okay, I'm going to teach you aldehyde ketone in a while. Copy this first. Alcohol, tertiary alcohol to cannot. Well, cannot is good news. Okay, so take some time to copy this down. Okay. So aldehyde and ketone, they are what compounds? Carbonyl compounds, right? Carbonyl compounds. Is it being tested for your March common test? I don't have much. Wow, good news, two of you, very good life. Don't have tests. Other students very stressful for tests, right? But if you don't have tests, I have to give you a bit of test. Don't worry. If not, cannot. No choice, can? No choice. I think I do some homework. I don't know you do that. You do the homework. Like 6 many years. Not many years. Sorry. Last week or previous week. Normal. That's why today I'm going to discuss this. Okay, come.
Your attention, please. The fire alarm has been activated in the building. We are investigating the situation. Please remain calm and stand by for further instruction.
Okay, so aldehyde and ketone, they are carbonyl compounds, which is another chapter. Okay. So okay, do your own legend. I got different colors. You either different color or different shape, right? So you need to know that this part over here, right, is a square. This one is a square. This one is a square because these three same conditions. So you can do your own legend, right? So the square, can you see? That means from aldehyde to carboxylic acid, from primary alcohol to carboxylic acid straight, and for secondary alcohol to ketone, I can use the square, which is two alternative, right? Either one, not both. KMNO4, right? Our different dilute H2SO4, dilute H2SO4, and heat. Okay, some school will reflux, then you adjust if you need to. K2Cr2O7, dilute H2SO4, and heat. So you can choose either one for the square. Okay, they are strong oxidizing agent in acidic medium most of the time and need heat. Okay, of course, there's this thing that I never put yet. I just put a triangle. Okay, so for the triangle, you can only use a milder one because I'm stop halfway, right? Aldehyde stop halfway. So the milder one will be K2Cr2O7, dilute H2SO4, and what? You can remember? You don't oxidize halfway, not all the way. I'm stop there, I stop, pick up. Heat with immediate distillation. Okay, see your school say what? Either heat or warm. So warm with immediate distillation. Warm with immediate distillation. Okay, so you need to understand the extent of the oxidation because I'm stop halfway. If not, I go all the way. All the way, I heat all the way. Some screw at reflux. Right? If not, I will warm only. And then immediate distillation or some screw at heat. Tertiary alcohol, good news. There's no oxidation. So easy. You understand? Opposite oxidation is reduction. So it's like opposite, but not exactly. So please be careful. Right? I start with your carboxylic acid. I reduce to form what thing? You can remember? Carboxylic acid reduced to form what thing? Just now our brain, just now, or it's just on top of the paper, right? So just now oxidized to carboxylic acid, so now reduced to form what? Okay, remember yes, it's primary alcohol. You cannot reduce halfway to aldehyde, understand? Right, just now you can oxidize halfway, but you cannot, you will just all the way because our good friend is too strong. Right, so this guy here is your LiAlH4, dry ether, room temperature. Must use this only, even though later got more reducing agent. Okay, so this is one, the first one. Of course, we can reduce the aldehyde, right? So aldehyde reduce to form what? Primary lah, because just now it came from there, right? Or ketone reduce to form what? Secondary alcohol. Like that, isn't it like the reverse? So same thing, these two, I put maybe a star lah, because we can have a legend again. Then use what? LiAlH4, dry ether, room temperature. Still got what? What's other reducing agent for aldehyde ketone? H2, nickel, catalyst, and heat. Right, and our good friend, our last one is a special unique guy. Yeah. Right, special unique guy. I cannot. Wait, what? Okay, the special unique guy is your, okay, then different school, different again, please double check can. Right, please double check. Number 3 will be your NADH4. Some school write in methanol, some school just leave it like that. Please check. In methanol, some school just put that and room temperature. Okay, so today or during tuition, I already help you learn fast. This is your revision time during tuition fast. Go back and try to look at the question and refer here and there and learn. Don't read notes this time. You can understand? Can you understand? Just like that, not too tough. Correct. Many students always forget. I don't know why. Okay, so this is your previous chapter. You should know this because previously you learned what in your halogen, but people all forget that. This is a big thing. What is it? What is the reagent condition? Right. Similarly, the reverse that actually previous chapter also learned. It's just different section. So the previous and this chapter very similar. It's the positioning of the sections only. Not too bad. So it's the reverse, but people always forget and be confused. So can you remember what are the reagents and conditions for these two? But anyway, you can copy the question first. And we are going to analyze the arrows, the reagent and condition. Second camera. Very funny one now. All learning. These two learning. We appear again this chapter. Previous chapter also learn. Now this chapter we learn again. Very funny. People forget. Very good. Which one? Top or bottom? Very good. Our fourth friend. So this one here, PCl5, right? PCl3, right? We can also use SOCl2 and dry HCl and heat. Basically, I'm substituting the OH, put a Cl in. Okay? This is called nucleophilic substitution. Wait, on top, what is it? You guys can remember the top one? No. Electrophilic sub belongs to a ring. What is that? What is this guy? What is this? What is this? What is this? What is this? Which chapter? Which chapter is this? Think of the chapter, then you can think of that a bit. What is this chapter? Not alkane, halogen, the previous one. Halogenoalkane, right? So halogenoalkane is your SN1, SN2, also nucleophilic sub there. Very confusing, So this is the previous chapter. So what is the reagent? To suck the Cl put OH. You can remember? Huh? Cannot. This is easier than the bottom one. So this is your, okay, so that's why I need to put these two, people always forget. And it always equals heat, right? So it's simple, you know. These two are called nucleophilic sub, strangely. Nucleophilic sub is also called nucleophilic sub. What's the difference? This one need to draw out mechanism, which is your SN1, SN2. This one, no need to draw out. I don't know how to draw. This part you better put together and your brain better process now, because commonly tested, people always forget, even though it's not too tough. I don't know why, it just cannot. So I say again, let's be very clear now. Don't learn the chapter. I mean, it's like chapter in your brain segment. But right, the Cl sub the OH sub the Cl. You need to know both sides. Always come out. Cl sub the OH, use NaOH equals heat. OH sub the Cl is our fourth friend. I can't use this term fourth friend. PCl5, PCl3, SO2, dry ACl. Right? So on top is the SN1, SN2 one. I need to draw one. Which today, no lah, lazy to ask you to draw. SN1 and SN2. We forget, better go and check. So this is variation number one. Since I'm teaching this, right? So for SN1, SN2, NaOH equals heat. This is the previous chapter. What's the second one? What's the third one? Got three variation, three nucleophile. Can you remember any nucleophile besides OH minus? So I'm talking about the top one now, the drawing one in the previous chapter, which discussed a lot. Can you remember any nucleophile? What can suck Cl besides OH minus? You can remember? Okay, must remember, step up. Why step up? Step up must be something that trigger you very quickly. What step up? Say again. Okay, KCN, right? Ethanol heat. This is in the previous chapter. And last one is what? NH3. Wow, this one very irritating, right? What's the NH3 irritating one? Concentrated ethanolic, right? Still need to be excess. And what's the last term? Very strange. Heat in sealed tube. This is the previous chapter. This is in the halogen chapter. The halogen derivative or alkane. Halogen alkane. Halogen chapter derivative. Right, your SN1 and SN2 cannot forget because it's always being tested. Everything will be tested, must be revised constantly and draw out your notes date line. Very boring. Resume. Let's go. So the alcohol, right, which I simplified, okay, I lazy, so I simplify this alcohol. Okay, so this is the alcohol. It can also react with sodium. Give you what? This is something like acid metal, but we cannot say that for A level. I don't know why I cannot. What is this reaction called? Oh yeah, just say right. So this is actually reduction. Wow, so tough. Sorry, I thought of this. This is actually redox. Even though unofficially is your acid metal reaction. Acid plus metal gives you salt and hydrogen gas. But exam, what is the name of reaction? Redox. But to memorize, acid metal, salt and hydrogen gas. Okay, so we put a half H2 to balance. Don't need to balance all times 2. Okay, A level. So this is mixed reaction of finish. So easy. Right, so put bit by bit in your head. Okay, next one. Look at this. Right, this is what is this name of reaction? I'll show you. This one plus a carboxylic acid. In your syllabus Sec 4, you also learn for. What's this? You can remember? Yes, very good. So O, C double bond O, R plus water. I am taking out my H and my OH. So I'm forming an ester here, right? This guy here is an ester linkage. You know ester linkage? This part. Ester linkage. So sad, you cannot say esterification, right? You got to say this reaction is called condensation, okay? Because, right, so this is a condensation reaction, you see? Okay, slowly, bit by bit, right? Later we summarize, check your notes so that after you leave the class, you at least have some of it. Section by section. What's the reagent? Jacob, can you remember reagent? Sec 4 learn, exactly like Sec 4. Reversible arrow, better draw. What's the reagent? Concentrated H2, SO4, and heat. Okay, and I say some screw up reflux, then you adjust, okay? Reversible arrow means what? Again, what is reversible arrow? Means the yield is 100% or not 100%. The yield. Oh, yeah, correct. So it's a bad. So A level cannot write this. A level, you write like that, you are dead. That means they say, okay, how you make ester, you can do like that. You are dead. Cannot, because the yield is not 100%. So A level, there's a better way. But you still need to learn this because they can set for you. You cannot propose to them, not fair. Okay, so what's the better way? Now, let me help you. So same thing. Okay, after this, we will take a break, push on. So this one here, the alcohol, can you copy again? But you need to convert this guy to be these, which I'm going to ask you what is it. Now it's very good. Full arrow. Wow, very nice. 100% yield, don't need catalyst, don't need heat there. Very nice. You get this. This is what you need to propose for A level. So you need to do this extra step to convert the carboxylic acid to that guy. This guy is called a acyl chloride. Acyl chloride. Same thing, you circle out HCl instead of water. So this just now was water, this is HCl. Also called condensation. 100% yield, no need catalyst, no need heat. Super good to get the ester. They try to understand this. They try to copy down, then take some time to understand first. It's the same thing like alcohol, but this part a bit different. PCl5 also can, PCl3 also can, and SOCl2. You cannot put HCl. I'll explain to you in 2 to 3 weeks' time when you hit that chapter. So you need to do the extra step of converting the carboxylic acid to an acyl chloride. Acyl chloride is more reactive, which is taught in 3 weeks' time. But now we accept it first, right? So remember, you cannot do the first method because the yield is not 100%. You got to convert that to acyl chloride, then the yield is 100% to get ester. So A level must propose the second method. So I say again, let me clear this method 1, right? This method 2. You need to do method 2 to get full yield. Right. So next one is called tri-iodomethane test. So this is a unique distinguishing test for this chapter and carbonyl. Carbonyl is the next chapter. Okay, so remember, they will give you a positive test when I see this structure strictly like that. Any alcohol that has this structure will give you a positive test. The long line means this part here, I don't know what, it can be R, it can be H. Not important. It's the top that I'm bothered. See, I simplify it just that. Later I give you an example. Copy down first, right? Or a carbonyl. Next chapter we learn. This guy one line, I also don't know what. Not important. Okay, is the yellow part that I do a cloud. That is important to have that structure strictly. CH3 means CH3. You cannot change to other things. Not R, right? It's strictly CH3 for both sides. Okay, slowly copy down the reagent. So I2, NaOH, and heat. If there's a positive test, you will produce a yellow PPT of CHI3. Okay, copy down. So as long as there's these structures, they will give you a positive test, and the positive test is the yellow precipitate of CHI3. Okay. Means what? Okay, let me show you the example now. Let me show you the example. Okay, finish copying. Means what? Okay, tell me. Okay, please draw this somewhere or you look at it up to you. Okay, whether is there positive test? Okay, wait. Show you something. Okay, we just adapt skeletal. Okay, so this is question 1. We just practice a bit. Okay, question 1. Question 2. We do 4 questions. Can you copy? As I copy, as I draw, you copy on your notes, and then you take which one you give a positive tri-idomethane test. Can? Okay. So 1, 2, 3, 4, some compounds will give you a positive test, some compound will not give you a positive test. Can you just write down on the paper? Pick which one will give you a positive tri-idomethane test. Right. So for 1 cannot, right? Because you know why? Our job is check the OH, the C here. And then this is like got 2 C's, right? Because on top, I say must only have 1 CH3, you can see? Right? So this one, no positive test. Second one, there is a positive test because this is a CH3, right? CH3O. CH3CO. Then CH3CO, right? This one, this part. Yes, this part, right? You must know that this part is the CH3, right? Can you see? So this part here is your CH3, C, and secretly 1H, right? But this one, no. But no worry, it's no need to be everything. Just one part means have already, right? So this one is has a positive tri-idomethane test. And last one, of course, double bond. So it's only a CH3. There is no H, so cannot. Then, okay, easy. So this tri-idomethane test, so sad. You need to write down and learn this is actually oxidation. What's the name of what's the type of reaction? It's called oxidation. Next time when I'm free, then I explain to you the whole thing. No need for now. So tri-idomethane test is an oxidation reaction. Right? How does it work? Or what's the equation? Next time then we learn. Okay, very good. Okay, let's rest a while before we look at phenol. Okay, so the last part is phenol, which I like because not many reactions. So phenol is actually the arene with the alcohol group here, right? Okay, so try to, okay, now you think through, right, how to do this conversion. Second, how to do this conversion, right, from the phenol to this. Or again, any other? Use what? Use what reagent? This one commonly asked. Commonly asked. Right. What is it? Use what reagent? Okay, we don't waste time now. I bluff you. No such reaction. Always ask people, always go and do nucleation, go and use the PCl file. They say, oh, I remember last time I learned PCl file, then you go and do it. Good news, no need. Because you know why? Always ask at exam for A-level what the reason. Try to understand before you copy. You try to understand. So the key idea is that, wait, I try to erase the top. Okay, no lah. So the key idea is that, you know what happened? Okay, understand first, then you copy. The p orbitals of oxygen overlap with the delocalized pi electron cloud. Means what? They form a overlap. So I say again, the first thing is the p orbital, right? The p orbital of oxygen overlaps with delocalized pi electron cloud of benzene. Always ask for A level, but people always takai, cannot get the few marks. Just understand and get it clear from now onwards, right? So the p orbital of oxygen basically is the place where electrons are overlapped with the delocalized pi electron cloud. The benzene got delocalized pi electron cloud, right? And then because of this, right, they have an overlap. So here got electrons, right? Because oxygen got lone pair. So after you say this, you must say that lone pair of electrons of oxygen delocalized into the benzene ring. So you need to have the overlap, then you need to have a pathway, a road, a belt, a conveyor belt, a path. Then the lone pair can delocalize the benzene ring, resulting in partial double bond character. So cannot break one. Very good. Cannot break means no reaction. Nice. Partial double bond character of the CO bond. Okay, so remember, it's like 3 sections. Section 1, you must overlap. Section 2, the lone pair can move inside because now there's a road or there's a pathway. Like in the airport, right? Your luggage can move. Then because of that, they move in, then they form a partial double bond. So when they move in, double bond character. I said, so when there's double bond character, cannot break one. Remember, you cannot suck away the OH of the phenol. Understand? No reaction. So this is always asked for A-level, the reason. Same for this, right? This chapter, the previous one also, there's no reaction. You cannot do this also. You cannot do this also. You cannot, okay, NaOH equals heat. Because of same thing. This one overlap with this one, lone pair, right? Delocalize into benzene ring, then leading to a partial double bond character. So arene with something that is not H, because the rest of the arene at the side all H. Arene with something that's not H, there's always partial double bond, then no reaction. Okay, so this is something for the phenol you need to know. Okay, then we move on to the reaction. Now, so phenol first reaction, same thing. This one, tell me, this one you know one. Thank you very much, 2 of you. Can you continue writing this? I believe you can. Finish off the equation yourself. I believe you can. Try. Okay, come take 1 minute, finish off the reaction, the equation. The first one is a redox, very good, similar to your alcohol, right? Half H2, right? Acid metal like that, but cannot say that. So this is a redox reaction, but this is a acid base or some school, right? Neutralization. So you get salt and what thing? Again, salt and yeah. Okay, not that bad. 2 reactions of phenol. Okay. I move on. Finishing, push on. Okay, there's also condensation, which is very irritating, like just now. Okay, same thing. Try to finish off. I believe you can. 100%, I bet you can. Thank you very much. Can you finish off this equation also and balance and try to think what's the reaction called? Try. Very good, both of you. Okay, by the way, what's the name of this reaction? Again. Very good. You see? Right, you know yourself, I never teach you, right? Condensation reaction, very good. But there's a bit of difference. Just now, the alcohol, this is not new, it's the same as just now, right? Just now, the alcohol is just, same, right? Condensation, right? Nice. You circle out the HCl come out, right? circle out this and this. Okay lah, condensation. But this one also the same. Which all of you got it right? Very good. Right? C double bond O. Wait, if I careless tell me, but I see out. Okay, open your eyes big. Okay, same. But this one, you got to put in NaOH aqueous. To make the phenol behind the scenes become this. Yeah, this is your NaOH causing this change. Because the phenoxide ion is more nucleophilic. Phenol by itself, okay, according to theory, I don't know, I never do experiment, I'm not in the lab, but phenol by itself, in theory or in A-level, you without NaOH, you cannot do the condensation. You need to put in NaOH to convert the phenol to become more to become the phenoxide, which is more nucleophilic, so that it can react or attack the carbonyl carbon. These are delta plus. Okay, right? This delta plus delta minus. This 2-3 weeks later that tissue. So the difference is this. You don't put this wrong. Okay, no need heat. Just you need to do acid base first. Then that guy is more electron rich. Then I can attack this better. He will kind of attack this guy better lah. By right, is like that. Azan. Okay, so we must have the NaOH. Don't put wrong. Very first. Okay, very good. Next part. Okay, let's proceed. Finishing. Okay, I can say finishing, but don't know I never finish. But finishing really never roughly. Okay, as I draw, you draw. Because this part here, I summarize it. After students draw this, they learn very well. So we should continue doing this format. Some school they have, some school never. Okay, very nice summary that has some pattern. That's why I do this way. Okay, they copy as I do, later I'll teach you. Okay, then I do the bottom part. Okay, come copy first before I will teach you. Come. The first one is Br2 liquid in CCl4 to have a mono-sub. Okay, OH group, if you check your data booklet, is a 2 or 4 directly. So there's a mixture of on the second and the fourth respect to OH. To have 3 aqueous bromine. Right, to have 1 Br2 liquid CCl4. To sub 3 aqueous bromine. 2, I'm not too sure. So when will you sub 2? When one of the 246 is blocked, understand? Later you check this question. You know the meaning of block? That means maybe here got something else. So I only got the 2 and 4 to play with. Right? It's just 246. I need 2, not 2. OH is 1, right? So it's 246. NO2, write down, dilute HNO3. You want 3? Concentrated HNO3. So this is a very nice summary, right? That phenol will test, because phenol nothing much to test. Few reaction only. Understand? What is the name of this reaction? Let me guess. Like that, that means these 4 is the same name. What's the name of the reaction? ETN, I guess. These 4 is the same name. Even though it's like different variation, bromine, NO2, all this, but it's the same name. Or they can help her. Very good. Write down electrophilic sub. This, how come I learned this now? Because if you spot properly, right, it's the benzene ring that is being affected. right? I'm reacting away the benzene ring. I know there's a phenol there, but the reaction involves the benzene ring subbing away the H with the Br or the NO2, right? So now my next question is, if it's a botak, what is it? It is botak. If there's no OH, what is it? That means if just a benzene ring, that means a benzene ring, and then I want to put the Br in. Can remember the reagent? Or a benzene ring, then I put the NO2 in. What's the reagent? Remember? No OH. I tell you. Br2 then anhydrous. Anhydrous what? AlBr3. Right? Can see this part? Br2 anhydrous AlBr3. And this one, wow, this one very irritating. Corn HNO3. You need corn H2SO4. You still need 55 degrees. Can see this is in the arene chapter. I'm drawing a comparison with the presence of the phenol group or the OH. Super powerful. Okay, copy down first. Here, I'm going to tell you this comparison. You try to write down first. If it's a botak benzene, no OH with OH. Anhydrous AlBr3. This dry. Okay, write properly here. Right, this part here is your anhydrous AlBr3. Okay. Then you want the NO2 go in, it's a concentrated HNO3, concentrated H2SO4, 55 degrees. It's not new, it's in the arene chapter. So can you tell me something? With the presence, concentrated HNO3, concentrated 55, with the presence of OH, makes the guy more or less reactive. The right side, no OH, right? If I draw a line here, right? On the right side, there, no OH. This one got OH. So with all these reagent conditions, can you tell me something? With the present OH, makes it more or less reactive. Makes the benzene more or less reactive with the present OH. Botak or OH, which are more reactive? Wait, again. Which are more reactive? Like this, just look at this. The left or right more reactive? That means, say again. Right more reactive. Again. Left more reactive. Left. You know why? You see, with the present OH, I don't need catalyst. Can you see Japan no catalyst? No catalyst. This one I need catalyst. You see? Similarly, with the present OH, I can only use dilute. This side I need the concentrated, then only kena one. You know? So the OH group is activating in nature. The OH group here is what? Activates the benzene ring, right? This is in the data booklet. It's also like they like to hint you explain. So amount condition enough for the electrophilic sub. Understand? Right? The OH group is activating in nature. Means electron donating. You can understand? Okay? Right? The condition mau one also can already. The other one is so harsh. And the last one, never bluff you, then we'll rest for 5 minutes. Don't need to do anything. Last one. Phenol with neutral iron 3 chloride. Violet complex. This is a distinguishing test. I also don't know how to draw. I don't know what this reaction about. I only know that when there's a phenol group and I put in the neutral iron 3 chloride, I see violet color. I also don't know what's going on. I don't want to draw also. So this part is a distinguishing test of phenol. The only phenol got like that. Distinguishing test for phenol. Don't know what. Okay, having said that, I'm sorry, this part here also distinguishing test. This is also a good distinguishing test because this guy here is this 246, this guy over here is a white precipitate. And also your Orange will decolorize. This guy is orange solution in your data booklet, decolorize. So this is also another distribution test for phenol, but not so good because next time in 4 weeks, 1 month later, I teach you nitrogen compound. Got one guy also do like that. But for now, it's like that first. So got 2 distribution tests for phenol, neutral iron 3 chloride, and aqueous bromine. Because you see a white as a very distribution, very distinct. Of course, on top also decolorized, but on top not white precipitate. Okay, so number 1. So how I do this? Straight away, I know that PCl5. So straight away in my head, I must think, hey, PCl5 is which chapter? You must have what, then can react with PCl5? Can remember? You must have what, then can react with PCl5? OH. So remember PCl5 can react only OH, whether it's the alcohol OH or the carboxylic acid OH. Right down somewhere, right? It can be the ROH or the RCOOH, both can. In the chapter of carboxylic acid, which is 2 weeks time or what, then I teach you that I will tell you that can again. So your mindset, PCl5 can substitute the OH from the alcohol and the carboxylic acid. So straight away, they say that, straight away like that, I know B wrong. B don't know OH. It's a ketone. So sad the others still have, correct? Then the next part is what is this? Ethane, what is this? Alkali, aqueous, iodine, what is this? Hydroform test, very good. Or the triiodomethane. Then you go and find which one now. Must have the CH3, must have. So cannot be carboxylic acid. Now my hydroform never have carboxylic acid. So the answer is ethane tri. Is it C or D? That has the triiodomethane or hydroform structure. Which one? Of course you can draw, but you can I power is. Can you tell me? I guess C or D has. C don't have. You know why? I draw C. What's the requirement? I need a CH3, OH, and a H. Can you see C got no H? Right? D has. D I draw out. Right? CH3, C, H. Can you see this one? There. It has, right? This one here. So answer B. Okay, so remember, we practice more, then we can get the structure fast or draw out lah. Never mind, waste 30 seconds, sure get correct. Second answer. Yeah, this how it works. Okay, let me proceed. Number 4. Number 4 is answer. You put C. Then what do you do? You put what? A. Let me see for a while. Nucleophilic substitution. Okay, when I spot this kind. When I look at this question, I know that the benzene ring is affected. Can you see like this part went into the benzene ring. So remember now, whenever it's benzene ring related, it has to be C. Electrophilic sub. Not today's chapter. Today's chapter never talk about this. So I say again, whenever a benzene ring is affected or is reacted, right? The benzene hydrogen reacts. It has to be electrophilic sub only. Okay, all this topical is still okay because like you follow the topics, but you must get used to it when it's everything combined. Okay, so when benzene ring is affected, it should be electrophilic sub. Okay, number 5. Number 5. C. Cannot. C is for C reacts with phenol. And that guy got phenol. Try it out. Remember that this is what Janashi asked me. So that is the last part that I teach you just now. Remember? So neutral iron chloride is normally neglected because it's a small part of your notes at the end and people forget it and there's no diagram, nothing. It's just words. So learn today, neutral chloride of phenol, strictly that only, very good. So C cannot. Aqueous bromine can or not? Can. Got the benzene ring, sorry. Got the double bond, aqueous bromine. Phenol also can aqueous bromine. So A can react. PCl5 can. Why PCl5 can? Left or right or both? The right one, you cannot say phenol. Phenol cannot substitute away. It's because of the terpiane, this one. So answer D. You can answer? Right? So KCN only for our halogen chapter, the SN, Nucleophilic Substitution, SN1, SN2. Practice, the only way to learn reagent is to practice. This is the only way, but it's very difficult, I can tell you lah. Right? But it's very difficult to follow. Try your best, practice. You'll find enough. Number 7.
If alcohol is that extend the carbon chain, is there any such thing?
Good question. The answer is, so extend, good question. Always come up for A-level. Extend carbon chain means step up. So remember, step up reaction only for Rx, which is your halogen, and your carbonyl.
Yeah, I want to step up, I do convert the Rx first.
Very good. So I say again, very good point. And exam always ask these. Step up means you can only go through carbonyl, sorry, Rx and carbonyl next week. I teach you next week or following week, see how it goes. So you need to convert to one of these first and can. Step up is your KCN. Always ask for exam. And then number 7. Underwent this, right? So PCl5. Wow, so difficult. Okay, so PCl5, then boiling with KCN. Then we step up, guy. And then after that, NaOH. So tough. Okay, don't worry, slowly. Now, step up. So the original guy must have 1 carbon less. This is the first thing I do. So can you see the final product, how many carbon? 1, 2, 3, 4. So my original must have 3 carbon only. So I cannot be C, I cannot be A. Do you understand? I say again, to step up means I increase by 1 carbon, means my original reactant A has 1 carbon less. Okay? Then after that, PCl5, our OH, then the answer D. Do that. You need to think. Because PCl5 cannot react with alkene one. Understand? Okay, so just a quick run through this guy, PCl5. So it's CCCCl. After that, step up. Substitute the Cl with the Cn. After that, NaOH is the basic hydrolysis. So becomes a COO minus. This is the flow, understand? Basic hydrolysis, Cn becomes COO minus is basic hydrolysis. Cn doesn't stop there, it always continues. So this is the flow of what's going on. So the first one is your PCl5. Second one is your KCN, ethanol, heat, and last one is your NaOH equals heat, basic hydrolysis. Chapters all linked, very sad. So you miss out one, then no problem. Hey, you can understand? Yeah. You can understand? Right. So this is a flow lah. Because synthesis is also very commercial. But the thought process is like that. Step up, I need to reduce 1 carbon.
Is Na plus there because
okay.
it is not
Na plus here, I forget to write.
No, the Na plus is there because it is in alkaline medium.
Yes, correct. CO minus Na plus, to be more precise. Alkaline medium. It is KOH and K plus. Just a side guy, not connected. Okay, last one. Which of the following will be formed when this guy is distilled with hot? This one, distilled. Distilled is the halfway. Distilled, remember the stop halfway? Remember not? Distilled with hot. This one, right? I believe they are hinting that. Okay, so let's take a look first. First of all, whenever I see this, a common mistake, people go and chop the double bond. Remember, to oxidize alkene, you can only use KMNO4. So my double bond will not drop. I say again, in the chapter alkene, in order to break the double bond, you need KMNO4. You cannot use K2. So my double bond will remain there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, my double bond will remain, and that's all. Answer D straight away, right? So my job is just to oxidize. Wow, this question very ambiguous, not so clearly. Right, this is a secondary alcohol. So it becomes, ayo, this is very not clear. Hot also. Okay, distilled and then they say hot acidified. Very scary. But that's the best answer. My double bond cannot change. Let me think for a while first. Yeah, lor. You understand? Double bond will not react. So answer is D straight. Can come look through any questions? Okay, what I can spot is the OH gone, but you cannot just take away OH, right? You got to eliminate together, right? Eliminate together the water. Ayo, this one a bit tough because you know why? There's a H here. I can choose to eliminate. I can also choose to eliminate here. Which H will be more preferred to be eliminated? The red or the blue? Because you eliminate different place, the double bond is different place. The red one better or the blue one better? Again, can remember? Say again. Red. Can remember? Because different place will give you different double bond. I'll show you both. Yeah, I'll show you both. Then you see which one. Okay. If I take the red, it will be on top, right? Double bond here. If I take the blue, it will be the green one here, right? Huh? No, the answer is the blue because forming at this part here has more R group. See the double bond, and then important. I form a double bond here. How many R groups around the double bond? 3, right? You know why 3 or not? You know why 3 or not? 1 R group, another R group here, like don't know where, stretch. And then here got one more R group, right? But if I have it on top, how many R groups are there? 2 only. More R group, more stable. So remember, you got to form the more substituted alkene.
The alcohol is
No, that's for carboxylic ion, not this. This one not syllabus, you just need to memorize. The double bond has to have more R groups around the double bond. Right? So remember, the blue one is preferred. Means this part will be eliminated to get X. X is the blue one that I've drawn underneath. Right? Take away the more substituted, form the more substituted alkene. Means the carbon of the double bond has more R groups. So what is elimination of water? The condition? Remember? Excess, what? Concentrated H2SO4 heat. And then chapter of alkene, alcohol. So this one I will teach you today, elimination of water from alcohol. But it's alkene you learn. Then how you put the double bond and clear it? From X to the final product, do what? Alkene chapter. So this chapter is alkene. This question is alkene. Put in what? Double bond to no double bond. Put in. Put in. What thing? From double bond to no double bond. Put in hydrogen. It's a reduction, right? In alkene chapter, right? Not today. H2, nickel catalyst, and heat, right? In the chapter of alkene or even in Sec 4. Sec 4 we say addition of hydrogen. A level cannot. You must say reduction of alkene. You get that? Double bond to no double bond is addition of hydrogen, but cannot say for A level, must say reduction. Reduction. First one is elimination. Second one is reduction of alkene.